Good morning, good afternoon, or good evening, everyone. Thank you for joining us today. This is the Kesh Foundation Spaceship Institute Public Teaching in English for Monday, November 20th, 2017. And as today, every Monday, this is the Understanding Plasma Science series. This is part 9 this morning. And we have Jim and Lisa McDonald with us, along with Shander Kakashi. So I'm going to be covering these topics today, again, of plasma science, nanocoding, and GANs. I'm your host, Flint Mulhausen. Welcome, everyone, and welcome, Jim.
Hello, Flint. Hello, Rick. Good morning, everybody, or evening, wherever you are. All right, let me get started. All right, you can see that, Flint?
Yes.
Okay, good. So we're up to part 9. So there's only 3 more after this one. So we're doing okay. We're covering quite a bit of information, and so we hope that you have been learning along the way, and there's still much more to come. Right, so today we will work on the plasma science, and we're going to look at the concept of positioning. And in the nano, we'll be doing another method, which is the using the flame torch method. And then in the GAN section, we're going to look at the creation of the CH3 GANs. And the technology is brought to you by the Kesh Foundation. All right, so we'll kick off with the concept of positioning. And when we're going through this presentation, one must bear in mind that it has relevance in all aspects of our lives. It's not just a case of crafts flying around. It has to do with positioning of the planets, but it also has to do with positioning in nano layers, and also positioning of the way we operate from a soul level. So it is quite an important section relating to everything. So first of all, we'll play 2 short videos, just so that you can get an idea of what we're talking about. So if you're able to do that, Flint?
Yes.
All right.
Yes, I am. Okay, first one's called Field Lines or Magravs. And this is off our animation series in our YouTube channel. Showing really quickly about magnetic gravitational and the different positioning of how that happens. And you wanted me to play the other one?
Yes, we can, Flint.
Okay. You can also talk a little bit here.
Yeah.
This is also a silent video.
Yeah. This one we've played very early on in the series of the workshops, but it's important to bring it back again, and just to how I'm moving the one magnet, the other one repositions itself to maintain that distance in the gap. And when you introduce a third one, now they all have to start interacting and find their position with each other. And these magnets are sort of on a two-dimensional plane, and they're all of the same strength. So if one were to imagine one of them, as Rick has shown, having a stronger strength, stronger magnet than the other one, how they then reposition. Notice how they're always wanting to move to get to that point of balance where they, all four of them, find their balance position. Thanks, Flint.
Yeah, sure.
Okay, so we have to ask those same questions now again, and I think hopefully we'll have some more, we'll have the answers for them. As what force makes these round magnets move? When you move one, the other one moves. So what force is making the other one move? Why they keep that certain distance from each other? And when you move one of them, how all the others will move as well to keep their distance. And so the question is, what is this connection that they all have? So it really comes down to the strength of each one of those magnets, or call them plasmas as well. And the strength between each one dictates this gap, dictates this distance, because you've got the magnetical and you've got the gravitational. So you have your repulsion and attraction. And as one moves, so the other must reposition to maintain this gap all the time. And when you're looking at the fields between the two magnets, the fields exiting the one magnet interact and into the bottom of the next magnet. And this is how they keep their distance from each other. This gap allows them to move freely, but they're still interacting with each other through the fields. So essentially the universe is built on these two forces, the magnetical and the gravitational, and one cannot work and exist without the other. So it's your two magnetic field forces, being the repulsion, and your gravitational being your attraction. So everything comes down to these two forces in nature. So when we have a look at the interaction of two plasmas, and now we can have a look at the proton and electron within an atom. So you look at the motion of the electron in relation to that proton is through mag-grav positioning, because they are both a plasma, they both have the fields, and so they're having to find their position in relationship to each other. So if you had to view them as two magnets, one big, one small, they're having to find their position. And so that's what we have inside an atom, is you have the proton and electron finding their position. Your proton and electron are independent dynamic entities made up of composite dynamic fields. So each one is independent, made up of different fields, but your proton and electron would be consisting of the same field. So what's in your proton is in your electron, but it's just on one's bigger and one's smaller, and so they have that interaction. They interact with each other on a continuous basis. So everything is constantly moving, trying to find that position between the two. And because of the dynamic nature of the fields in both the proton and electron, they're always wanting to find that position. As something changes in the proton, the electron will have to adjust and move, and vice versa. Same as the electron will adjust, the proton adjusts. So the two are always interacting with each other. And the ever-changing position of the lighter by mass of the two entities, in this case the electron in relation to the proton, gives us that motion. And so this is essentially what we would call mag-rev positioning within a single atom that has a proton and an electron. And as we've explained before, when you're doing your nanocoating process, and it's particularly during your drying and curing process where you're leaving your plates to sit for weeks at a time, this is what those tiny atoms are doing, is they are trying to find their position in relationship to each other. They're moving around, constantly wanting to find the position, and as the strength is changing, so they will move until you take them out of that container, and essentially then what you have created is then set, because now you take them out of that environment when you want to end that nano process, and you want to wash and end that moving and positioning of those atoms within your nano layers. The same concept can be applied when we look at how planets are positioning themselves in respect to the sun. It's all based on magnetical and gravitational forces. And it's the strength of each plasma, whether it's the sun in relation to the Earth, which dictates that too, and the movement. And as the one moves, the other one repositions. So that's how your planets are positioning themselves around the sun in our solar system. And when you're essentially looking at the concept of the sun and the Earth as two plasmas, it's the same thing whether it was a proton or electron. It's now the sun and the Earth. It comes down with the interaction of the fields, and it's just the mag-rev positioning of the two, which gives us the motion. And we can take it that next step further in terms of our solar system within the galaxy, is also, and the movement is also through mag-rev positioning. And when we come back to Earth, when we start creating the craft, which will have its own magnetic gravitational fields in relation to the Earth, it's also going to be able to do travel and movement through mag-rev positioning, where no fuel is needed. So essentially, we're going to learn to travel in Earth's condition, because within Earth, we have certain set of magnetical and gravitational fields. And when we start traveling in the solar system, we're now traveling in a different condition, a different magnetic gravitational fields. And as we move from our solar system with its magnetic fields into the galaxy and then into the universe, so we have to learn the different conditions in which we're going to be traveling in. So when we come back to the concept which we have introduced before, is in terms of gravity and the way we understand it here on Earth, is the measure of the interaction and attraction of two or more magnetic rays or magnetic field systems, or in sense two entities, with respect to each other's strength and position at any point. So, in other words, we have two plasma entities do interact in position. The much stronger one will pull in the weaker one. So that's how it's explained if we look at ourselves as a smaller plasma in relation to the Earth. All comes down to maggrav positioning. All right, any questions on that one? It's very short, but it's quite important. It's sort of a very important principle throughout this technology that we need to understand.
And I can remind everyone, you can always raise your hand if you're in Zoom here. And also type in your question if you're on Facebook, live stream, or YouTube. I don't see any questions.
This is, I'm sorry.
Yeah, go ahead, Boniface.
This is Nicholas.
Or Nicholas, sorry.
So we have what we call the gravitation of the Earth that holds objects to it. So if we look at ourselves, for instance, or an object in relationship to the Earth, is the Earth magnetic, gravitational? Is it stronger because of its size, of its mass? Is there a relationship in that way, or are we looking at something different here?
There is a relationship in size because it's the same when you do look at the sun and the Earth, and it comes down to the strength, the field strength that each one possesses as well. So the size and coming down to the mass of each object, it does play a role as well. But if we're able to understand, sorry?
I was wondering then what causes the rotation or the movement of, say, the Earth and around the sun. Is that connected to the fields as well?
Yes, I didn't bring in the rotation because it's sort of it is a different concept, even though it is related. But the rotation of the Earth is more to do with sort of complex layers within Earth of the different fields, which causes the rotation in relation to its positioning. So that's a totally different concept, which gives us the spin. So we won't go into that for this workshop.
So the Earth is positioned in relationship to the sun. Where it is, if it gets closer, it's pushed back. If it gets further away, it's pulled forward. So our position, which say is individual Earth as an entity, could be controlled that way. But we could also look at the Earth as a sphere, as an energetic sphere around the sun, and the Earth is just the physical representation of that spherical field. Does that make sense?
Yes, because we're connected by the fields, and if we're looking at the two objects, if we start, and that's how travel is going to be made possible, because if you are able to change, say in your craft, change your magnetical field or change your gravitational field within your craft in relation to Earth's fields, then you are going to either move yourself closer to Earth or move yourself further away from Earth by changing your conditions of your craft. And it's just either adjusting the magnetical side of the field or the gravitational in relation to your magnetical.
Why then would an asteroid or a meteorite or something like that then be drawn all the way into the Earth?
Did we lose Jim?
Hello? You want to just finish there, Nicholas?
Well, I just wondered why some objects like a meteorite or something like that doesn't have a position. It's drawn all the way into the Earth, where the Earth is not drawn into the sun. It has a position.
Well, because we're not drawn in, because Earth, besides having its gravitational fields, also has magnetical fields, which all entities have both magnetical and gravitational. And so they find their position in relationship to each other. If one maybe looks at the sort of a meteor, its magnetical is probably a lot weaker than its gravitational. So it's able, that's why it gets attracted to Earth. Because like attracts like.
Great, thank you.
Jim John here. Good morning.
I have a question, please. Can you hear me?
Yes, we can.
Okay. According to this theory, don't you think that asteroids couldn't fall in the planet because they must reach a stable position in the system? What do you think about it?
I'm sorry, I'm not understanding your question.
Yes, I'm trying to mean, according to this theory of the stable positioning of the
Two
system,
objects.
the planets and other asteroids, for example. Don't you think asteroids could not fall in the planet according to this theory because they must be in a stable repositioning system in relation to the planets? What do you think about it?
It depends on what is the magnetical gravitational fields of that asteroid in relation to the Earth or in relation to the Sun.
And also the asteroids are actually positioned in the asteroid belt. Most asteroids are not traveling through the solar system, and it's the meteors and meteorites that hit the Earth's atmosphere. Asteroids aren't usually entering the Earth's atmosphere.
Right, and I see it as, you think of it as the electron, proton, neutron, and the actual atoms, and our solar system can be like an atom. So we have ionization of atoms, which means that they have free electrons which move around in between the atoms, but also not in a stable position. And that's where I think you can get the asteroids coming from. You can think of them as like the electrons flowing around inside of an atom that's been ionized. So you have energy that's coming in and out of the solar system and the galaxies. So the ionization is definitely possible, or the movement of asteroids or other particles inside of the solar system.
Hello, Jim. This is Boniface.
Yes.
Thanks for your presentation. I have a quick question, if it's not out of the scope of what you're describing. You talk about the magnetic force and the gravitational force. There's also inertia, which is somehow related to gravitation. Can you talk about that a little bit, or is it out of the scope of the presentation?
Yeah, it's out of the scope, and it is something that I do not understand fully myself, so I don't even want to try and explain. So.
All right, thank you very much. I appreciate it.
Okay.
I understand. I understand inertia as the movement of magnetic fields within another field. That's what I understood inertia as.
Jim John here.
Yes, John?
Yesterday, I put in our internal chat something I found which is very interesting. An Iranian scientist called Paris Polter, a woman, she talks about gravitational, not tied to mass, if not tied to area, which is a very good point, because I would tie inertia to mass and gravitational force to area, which is a very nice point of view. And she demonstrates it mathematically in her book. I haven't read the book, I just read the commentaries, which are very, very good, very interesting. And she comes from a similar background from Mr. Merenkesh. And she has a few more years than Merem, about 10 years older. So she's got a different point of view, very interesting. It's worthwhile only reading the commentaries. It just gives you another idea of what gravitational is, what is inertia, and so we can visualize gravitational with magnetical very much on the same level and not tied to the inertia and the mass.
Thanks, John. Any questions on positioning?
Yeah, there was one in live stream from Jeremy asking in relation to the spacecraft positioning. Does that mean that in order to fly or hover, the craft would have to have a greater field strength than the Earth?
You have to adjust and create your magnetical gravitational field in relation to Earth, and then adjust either your magnetical or your gravitational, depending on where you're wanting to go. But yes, it would have to be of a strength equal to, or more than or less than, depending on which direction. It does. When you're looking at the positioning, it does seem quite simple, but obviously when you're creating spacecrafts and all that sort of thing, it is a bit more complicated than that. But it is just a case of two magnets interacting, either attracting or repelling away, or finding their balance point of positioning.
Could I add something else, Jim? When we look at the magnets, we're visualizing in a two-dimensional way. When we go into 3 dimensions in space and we see the way positioning of the galaxies take place, we sort of think, well, what happens if a planet inverts its magnetical polarization, which it does according to what we've studied or been taught about. The magnetical force would flip around and pull the planet with the sun together, just same as gravitational, because we're tying it in a way with what I've commented about mass. Now, if we think of it as area, it's different. It's a new way of seeing these forces in a 3-dimensional way. It's a bit complicated because if we're only tied to 2 dimensions, our table is holding us straight. But what happens when the magnet flips over and it just bashes into the other one? It's a good exercise for our mental thoughts, I think.
Thanks, John. Any other questions, or we move on?
In the positioning then of the planets to the solar system, and you know they're relating to more than the sun, but it seems to come back to this sort of dish shape where the sun is in the heart of it, but everything moving around it in terms of the planets seems to be in one area. It's not over the whole thing, creating kind of a dish effect around the sun. So there's something holding those positions, not only in terms of distance in relationship to each other, but also a pattern or a geometric form or design within it. So there must be other elements or forces involved in creating these forms.
It's a good point, because one has to understand that our solar system is also very much influenced from the galaxy and other solar systems within the galaxy, because we can't view our solar system in isolation. So it's interacting with all other solar systems, the galaxy and the universe. It's all, everything is having an impact in terms of positioning and change. So,
well, even when we look at pictures of what we would call a galaxy, assuming they're accurate, then the galaxy also seems to have a dish shape or a flattish spiraling shape.
yeah.
We've got many different galaxy shapes. There are some more like a ball shape. Don't forget, we're in 3D, and remember that our solar system travels as a corkscrew towards or away from the galaxy center. We've also got to visualize that. Don't think of the solar system as a plane where we're fooling around with magnets. We're in space in a corkscrew effect, and everything is traveling together. Whatever bit of dust in space is nearing or getting away from the sun or the earth, it is traveling in that corkscrew effect. If not, it only comes in circumstantially once in contact with our interaction of our solar system.
Can we just try and bring the topic back to keep it simple? Any questions before we can move on?
I have another question, Jim, please. João Batista from Brazil.
Yes.
I think there's not the same the position considering the atom and the solar system, because in the atom you have a electron orbit in kind of spheric shape, and in our solar system we have an ecliptica, a plane where the planets orbit the sun. What do you think about what this difference is in relation to repositioning? Thank you.
Well, even within your atom, the electron is positioning itself all the time. So it's coming in closer and moving further away within a band, within that sort of certain range, depending on its strength. So the planets are also doing that in a sense as well. They are moving in their shape, different shapes depending on the strengths.
Also important to note that the time scale is, we're only seeing it the way it is now. We're actually in a spiral, not in we're spiraling into the sun. And eventually all the planets will spiral into the sun. It'll take a long time. It's not going to happen tomorrow.
No, it's not. Yeah.
All right, is that it?
There was a statement on Facebook here saying the magnets are just to illustrate the fields, right? I mean, not every field is repelling or attracting like magnets do. Otherwise, you would be pushed away from your position when another person comes close to you.
It's just an illustration. It's just trying to get the point across how we interact. You know, we're all made of the fields, but we don't see the fields. And the magnets is quite a nice, it's just an illustration to show that the effects of the fields on us. But yes, you know, we walk past somebody, we're not going to bounce off them. But there are those fields which we're interacting with.
But in a way, you're also repelled when you're not, you don't congeniate with that person.
Yeah, on emotional level, you know, where you meet somebody for the first time and you either like that person or there's just something that, or, you know, that doesn't agree with you. And so it is the attraction or repelling of the fields that you do pick up. So in a way you are sensing that, but on a different level. It's not on a physical matter level like the magnets. You know, so it has implications when you look at it from a soul level, and why, you know, certain people, certain group of friends will get together is because they are of similar strengths in their field strengths, so they will get together and enjoy each other's company. Whereas somebody else coming into that group might not feel like he's welcome or fits in because he's just not of the same field strength as that particular group of people. So we experience that in a different way, but it's essentially coming down to the same principle of positioning.
Can I add something, Jim, please?
Yes.
If you look to the magnets, just visualize that these two magnets is cells in your body, one cell here and one cell here. And in little bit bigger scale, this magnet is one organ in your body. And in bigger little bit scale, it is a bigger organ in your body. And so until you are one human being. One human being is a universe. Every part of him have 1,000 of galaxies. It's the same thing, the same system, the same law goes. What you are seeing, the planetary and the solar system and our universe, it's the same thing. But don't take it as a two-dimension. Take it as a ball. And actually, this every cell of us is a ball. Every time it's circulating, every time it's repelled, every time it's attracted to others. And this has become emotion. And everywhere there is an emotion. In all cells, in all items, all the entities. So plasma everywhere is an entity. And when it is produced, that means it have intelligent. It's very simple if you put it like this. If you want to go deeper, how to understand, it is your position where you are sitting in a bus or you are walking in the city or you are in your home. Every one of us have his position. Sometimes it attract near to the other person. Sometimes it's repel, have a bigger distance because situation, the condition, the maghraf position, due to your own situation, due to your own gravitational magnetic field, what you are getting, what you are giving. I see it in this way, and in this way, it simplifies everything I feel and I see. Thank you.
Thanks,
I
Jalal.
see.
A very nice way to summarize all that up for everybody. I think.
Could I add something else?
Can we move on, John? Because we're just looking at the
Well,
time.
fine. Let's not forget resonance also.
Okay, thank you. Okay. So the next part is the nanolayering with the fire method. And I'm glad to see that Sandor's with us, because my experience with the fire method is very, very limited. I just have tried it a few times and not very successful. As I'm going through, in Sandor, if you're welcome to join in and give us comments as we're going through.
Okay, I'm here. I hope I will have no internet interruptions. So now it's Monday morning, so people are at their jobs in this district, so probably will be the bandwidth. While yesterday it took 15 minutes to transfer a 2 megabytes file. It was Sunday. So let's hope it will be all fine. Eventually also my video can be started if the host would allow.
Thank you, Sandor.
Okay.
Okay, so the fire method of nanocoating is using a gas burner, something like that in the picture there, butane gas. And so what you're essentially doing is you're heating up the copper of your coils, and you're using the flame, and it's a case of understanding which part of the flame that you're wanting to use, which region, so that it can actually work on your copper. And I think, Sandor, this comes down to a lot of experience and a lot of art to get this one exactly right.
Yes, so if you have seen painters, how they work with a brush, how they paint in such a way that there are no stripes, but everything is uniform, like with spray paint. So same or similar skills have to be attained when you work with a flame. It's exactly like when an artist works with his paintbrush. So now there are two important points to remember. One, to achieve the right temperature, around 630, 650 centigrades, which you cannot measure usually if you have no special instrument, but you can judge by the color of the surface. In no case you should rise the temperature until the copper becomes red hot. So that's the second point, to never overheat. So if you overheat it, if the color of the heat with the surface will become, even for a fraction of a second, such a red hot, in that case your coating will be ruined because it will pop off immediately. So it needs some practice. The good way is to sacrifice some pieces of copper. You make some dummy coils just for trying, for testing, and you practice on that to find the right pace. So you never hold the flame in one place. You always keep it moving from one end to the other. And while going from one end to the other of a copper wire or a copper plate or a copper coil, you also give the direction, from which direction to where to grow these layers. And you start and you heat it a little bit and you keep moving. Better go over 3-4 times until you reach the right temperature. The proper temperature, it will be shown as a silver metal shiny color. It will be just like a mirror, a silverish shiny color. So now It depends of your kind of gas and your kind of torch. There are torches of lower temperatures, of higher temperatures. It can be propane, propane-butane, or methane gas, the methane gas, does not matter. You have to find that region of the flame, which is not at the top, but it's somewhere inside, where you get constantly the same useful temperature. So you will exercise a bit just as a hint. Try this 1/3 from the top of the inner flame. You will see the flame, it has an inner one which is more bluish, and you will have an outer one which is more purple or violet color. So try to use that inner cone of flame, and not the tip of it, because that's the hottest, but somewhere inside, maybe at around 1/3 or half. It depends of your kind of gas. So you can make very good nanocoating with flame, but it really needs some practice. So there is a nice video made by the PID department, Product Innovation Development Department. So that would be nice to see it. So it's something you really have to see it to understand it.
It's sort of 10 or 12 minute long video, so I didn't want to play it today, but I do recommend that those who want to do the flame is to go and watch this video. It's a very good video, and it shows you.
You may show Jim, at least 2 minutes portion of it, something from the first part of it, when it starts changing the colors. It really doesn't take too much time, just as an idea, and people will watch their free time all the video.
Flint, I haven't asked you for that video. Are you able to get it, or?
Yeah, give me a little bit here.
Okay. Right, we'll carry on then. Well, Flint finds that video. All right, when to use this one method. Sandra was saying it requires some skill. So I've tried it and not very successful. Where my layers keep on flaking off.
So what can happen if you ruin the coating? You just repeat it. So the good thing is that after you overheated the copper, you can go again with the flame in right temperature, at the right temperature, and the new layers will be created, and the old one will pop off. So we use it when we have no time to do a process which is several weeks, like the caustic immersion method. So when you have a very short time, like you are in a disaster area and you need quickly to find something to make some nanocoated copper because you want to purify some water, or you need to make some gases. In that case, if you can make a fire, even if you have no gas torch, but you just have a fire of charcoals, you wait until the flame goes off, and when you have the live coals, without flame, only the red hot charcoals, in that case you can hold over it at a small distance the plate without touching it, and you can heat it up until it changes the color. It becomes such a metallic shiny, like a shiny silver surface or like a gold surface, and then you will see the color, it turns in a grayish color. You don't expect to get a black color, just to change its color to a matte gray, and then it's fine. So also the PID department found that the nanocoating made by the fire, it's supposed that it's more good for magnetical purpose coils, or for applications where you need a more magnetical character of the nanocoating. And when you make the nanocoating by caustic, in that case that will be more gravitational. It has to be verified, this information, but we got once such a hint with such an idea. So I used, for testing purpose, I used such a fire nano-coated copper wires or copper plates for making GANs. And this coating doesn't last too much, so it goes off faster in a salt water. But it's very easy to renew it. You just take it out, you use the flame again, you refresh the coating, you wait until it cools off, you put it back into your GANs kit, and it works again. And another thing, you don't expect to get a perfect nano coating by fire at the first move, at the first operation, the first process. It's better to repeat that nano coating by flame 5-8 times.
Hello.
So yes, hello?
Hello, yeah, you called me in. It's Caroline.
Hello, Caroline. We were just explaining in so somebody pushed the button to call you.
This is the
that's
understanding
okay.
class, science class Monday mornings.
Okay.
Okay.
So
can you call Flint? Sorry, Sander. Flint, can you call me again because my phone is locked?
Yeah, no problem.
Thank you.
Go ahead, Sander.
Okay, so to achieve a good nano coating by fire, it's good to repeat the same operation 5-8 times. So you do this heating, you see the color changes, and you make sure you didn't overheat. You let it cool down for a couple of minutes or 30 minutes, and you repeat the process again. Again, you let it cool down, and you repeat it again, and you will see a more uniform surface, but don't overheat it. If you overheat it, it gets ruined. So now, grace to Mr. Veselin Velichkov from Bulgaria. He's a member of Bulgarian Academy, and he has access to scanning electron microscope. He has posted some 2 years ago such a scanning electron microscope photos about different types of nanolayers which he created, so some by fire and some by caustic. So now please look to understand these pictures. There is always a scale of dimension here. You see between this, the ends of this white bar, or between the ends of this black bar, you see it's a 10 micrometers. So it's a 10,000 nanometers. On the other picture, this distance is equivalent to that 10 microns, 10 micrometers. Just something strange happens on my screen because all my drawings look double. So maybe I try to make to go on full screen. So again, so from here to here, it's 10 micrometers. Can you see the drawing in a proper place? Because I see double.
No, we see it in the right place.
It's good. So on the other drawing, where is this caustic, it's such a small, maybe 6 times smaller, or 5 times smaller distance. It's equivalent to the same distance. So the picture on the left shows nanocoating by fire, and it's magnified 5 times more than the picture on the right. On the picture on the right, it's the method with caustic. On the internet, there are pictures with much closer photos also of this surface, so with higher magnification, but where you will see some big copper crystals, and you will see some fluffy things on the top. So these fluffy things, which you see here like a moss, so these structures, so these are the fine sp2 nanolayers. So you have to understand, when you look at the scanning electron microscope, if you have the shiniest metal, which is polished, you will see it like mountains and valleys, so don't expect it will be very smooth. But this shows, these pictures show the difference in between. So fire nano coating has a smaller grain and a finer structure. It's a much smaller one, a much finer grain than with caustic. So that's why it has different physical properties. So you still can use both for making a GANS or for nano-coating a coil, but don't expect exactly the same result. So there will be always a slight difference in between.
I have that video ready.
Oh, good. Let's watch.
I don't think there's any sound.
Maybe the sound is not shared, but it shows, well, you start in one end and you follow the path of your energy flow in the coils, how you intend. This is the way how you give the direction with the flame. Start with one, you keep it moving always, and you see that shiny metallic color like a shiny silver. That's the temperature which you have to reach. With some burners you achieve it very fast, with someone slower it's better to have a lower temperature burner. Okay, and now it starts going, and you have to keep moving to maintain the same shiny color under the tip of the flame. If it becomes such a many colors of the rainbow, it means the temperature was not uniform. So it depends of your gas burner which you use. With some gas burner you have to work really fast. With some, like here in the picture, in the video, you can go a bit slower. But basically you keep it moving. And you see the result will be a uniform, either bluish or reddish dark color. When you see that shiny metallic color, that's the right temperature. And you see here it didn't got yet a uniform temperature, so it got some colors of the rainbow. So now it goes over again, and it's fine. So one of the coils. So now the next will be the next coil. And this you have to repeat it on one side, on the other side also. Just be careful and have patience. Better achieve that result in several steps than to overheat it. So now it goes the same from the other side. Of course, this you can apply also for plates, for wires, for whatever kind of surfaces of copper. You cannot do this obviously for zinc, for instance, because it will melt. It will not never nanocoat. It's suitable for certain type of metals which have a higher melting temperature. You can try to do this on nickel, for instance, or silver, but never on zinc or magnesium. Magnesium would burn instantly. So again, starting to heat it up until it reaches that shiny color, not more. And then it has to go. It's preferably to go just in one direction, not to go too much back and forth. The best is to use just a gas burner like the plumbers use for joining together, for soldering together the pipes. I did a mistake that I bought a Rothenberger Multigas 300, which has a too high temperature, so it was a torch for brazing, not for soldering. So it's not so easy to use. It overheats very quickly. Thank you. I think from this it's clear, so you don't have to wait till the end of the video. It is 5 minutes or 4 minutes way enough, so people to have idea about what's the ideal aspect, how it should look like, the surface of the copper at the right temperature. I think next slide was about possible problems which could arise. So you may obtain a very nice black or dark gray surface, and when you touch it, you see it goes off, or just you keep it hanging, and the next day you see everything is fallen out. The flaking of the layers happens if you overheated the copper. If you reach 700 centigrades, it's already overheated. So we have to take care to never heat it up to red hot color. So there is a remedy for it. You can rework the surface later with the flame of the right temperature, at the right pace, the right speed. Another thing which may happen that the surface is not uniform, but after you nanocoat it, it has many colors of the rainbow. So this happens when the heating was not uniform over all the surface. So as a remedy, you can reward the surface with the flame, again at the right temperature, at the right pace. So my advice was to better work over the surface 5, 7, or 8 times with cooling time in between instead of overheating the surface. So better be patient. You can make beautiful nanocoating by fire. If you don't want to reach the most perfect surface at the first, but you reach at second, third, fourth time when you go over. So because it needs some skills, it's really an art. So if you are able to paint a uniform painting or a lacquer surface with a paintbrush, probably you have enough skills to work with such a flame nanocoating too. Any questions? Are there any questions regarding the nanocoating by flame?
Yes, a couple. One would be, can you use a kiln to heat up the copper to a certain temperature?
Kilns can be used for creating nanolayers, but you cannot give the directioning. For our purpose, when we have the purpose for making an energy flow, like in a maglev coil, for instance, it's preferable to do this on a gradient way from one end to the other. In this way, you give also a direction, which in the case of the wet methods, you obtain it by discharging the voltage from the surface with a voltmeter. You cannot do that on the hot wire, but you can give a direction of the layering from one end to the other by moving the flame in a specific direction. If you use a kiln, and if you can set up the temperature such as 650 centigrades, for instance, or something above 400 and so, of course, you can create nanolayers, which would be great, for instance, for a capacitor, a supercapacitor, and so on. If you keep the growing of the nanolayers for a certain time, you can even grow such nanowires on the surface like a grass. But it's not always the purpose to make that. And our purpose is to teach easy methods which people can use it at home, and not everybody can get a key in such for laboratory. If you look through the internet to find research papers about nano copper oxides, you will find many such publications where scientists created different qualities of nano copper by using high temperature. But the structure, the surface, it's different. Usually they use the kiln for growing nanofibers which has the main purpose to increase greatly the surface of, let's say, a 10 by 10 centimeter copper, so increase the surface like it would be 10 by 10 meters if you can create enough such a glass, which is a part of the study in nanotechnologies for developing, so for instance, supercapacitors. You know, horses for courses. Find out which method is good for which purpose. Anybody can make a fire, a wood, and can make a nano coating even in a jungle, in a forest. But not everybody can have a kiln at his home laboratory and in his kitchen or in his garage. Getting a fire or a torch, a gas, or you can use the gas from a gas stove where you used to cook your food. It's also possible. Tom Salas has posted recently on his Facebook page such a short, very short half-minute video about how he nano-coats a copper plate over a gas stove, a gas kitchen stove. And it works fine for making dense materials. Other questions?
How about
Yes, I have a
combining
question.
two processes?
From João Batista from Brazil, I have a question. Have you heard about someone tried to use Brown's gas as a flame to nanocoat? Do you know what is Brown's gas?
Brown's gas is a mixture of hydrogen and oxygen.
Yes, Jeff.
It's created by electrolysis of water, for instance, and that flame has very interesting properties because it has apparently a low temperature when it's an open flame, but when you put some metal there, the temperature can increase at very high temperature. That's good for cutting metals and not so good for nano coating, because at nano coating you don't need 2000 centigrades, you need only 650 centigrades. So that's why brown gas doesn't look like the best choice. Of course, you can make a special burner which doesn't make a fire cone, a flame cone, which would penetrate deeply. But if you have a different burner with many small flames, with some manifolds, so anything you can, which you can use for creating the proper temperature can be used for this nano coating. But I don't think Brown's gas is the best, would be the best choice.
Okay.
Usually
I will try because I fabricate this kind of electrolyzers. I have so.
So you may try. You have to find the right speed, how fast you have to move the flame to not overheat it in one place. It's a matter of skills.
By the distance of the flame.
The distance, the portions of the flame, more inside, more outside, it's a different temperature. So I didn't work with Brown's gas. You will need to experiment by yourself.
Yes, I will report later. Thank you.
Thank you very much. So the beauty with nano coating by fire is that it's an easy, a fast method, and of course it needs some skills, but if you have the knowledge, you can use it even on the top of the mountain or in a jungle or anywhere where you can produce a fire. You don't even need such a gas burner if you can do a proper campfire, and you don't work over the flame. In that case, you work over the charcoals. Somewhere I have some photos about that. Just a second, let me open the right.
How about combining the two processes, the flame?
It's a bad idea. It's a bad idea. People tried it and they failed. So you know what happens when you do the hot caustic method, then previous layers will fall off. So that's why you usually use a hot caustic immersion method for nanocoating. And you use a steam caustic method for refreshing the coating or adding a secondary coating on an already made coating, which is nano-coated. You don't immerse it again into the hot boiling water, the hot boiling caustic, because the sudden dilatation and contraction of the surface will make the coatings to flake off. So if you think to nano-coat by fire first and to put them in hot caustic, you just wasted the first operation. Let me share here a picture. So this is a hot surface of live coals. So after you make a fire, you just wait for this moment when you have no more flames. You just have such a hot charcoals, and this is the moment when you can fry your steak or when you can nano-coat your copper pieces in safety, never on a flame in case of campfire. So if it is just a second, when it is such a grayish, you just blow a little air on it, so you remove the ashes from the top, and you will get this hot coals, and this is the best to use. So certainly you will need pliers or pieces of wire or something to hold from a distance, to hold your copper plate or copper wires at a distance in proximity of this heat source. And there also you have to take care to never heat it up to hot red. So these were my photos of my campfire.
Thanks very much, Sandor. Any
You're
other
welcome.
questions?
So, Sandor, going back to the question of combining processes, are you saying then that you could do fire coating followed by steam?
That's possible, but still a big question mark. You can try, but eventually for research purpose, we have no proven data that such a combination would be the best idea. You see, if you have a dough, you have some flour, you have some salt, you have some water, you mix it, you make a dough. So now either you fry it, either you boil it, and you make different kind of things. But you never fry and boil the same thing. But you may try. We do not advise to mix the methods, but you may try, and you can relate. You can report later the results and observations. So there are so many combinations which you can do. So maybe you get different results with one, different results with another. You know, no method is wrong, but just different method gives a different result. I tried to do such a thing. I was curious, like you were. So I tried to nano-coat first with flame, and later I put in caustic, and I didn't got a good result. So actually it happened that I wanted to nano-coat by fires, and the coating was not very good. I had not enough experience for that. Later I put the same plate into nano-coating by caustic, and the results was still not the best. So it's better to go either one way, either the other way if you seek reliable results. If you do testing experiments, no problem. You do whatever you wish.
It seems that the suggestion to fire coat coils and to use the caustic method on plates, that seems to be out there. Is there Any difference in the process for plates? Is there any reason one shouldn't use the fire method for plates?
If you have access to hot caustic nanocoating, it's best to follow that. So that's the most versatile method, which gives very good results. You see, in factory production, there was some production in Philippines, locally at a small scale. There's some small scale production facilities in China. They have been a big production facility in Italy and so on. And at the beginning, it seemed to be a good idea to do the nanocoating by fire. We know an engineer from Canada designed a special machine which you can program it with the robot. You adjust it exactly to the shape of your coil, to the temperature of your gas burners, to make a perfect nanocoating by flame, by robot. And finally, we see this manufacturing facilities finally prefer to use for the best results nanocoating by hot caustic method. So you can use if you are in a country where you cannot get caustic, you still can use nanocoating by fire. But the results are not so constant like when you do with hot caustic. You see, when you do the nanocoating by fire a couple of times, let's say you make 100 coils and you nanocoat all, and then you will compare the quality of them. You will see a big spread in the quality. It's very hard to make it uniform. Still, you can use it for nanocoating, but it's, as I said earlier, it's an art to make a very good quality nanocoating by fire. And when it comes to productivity, you may think, how would you like to have 99 pieces good out of 100, or to have 60 pieces good out of 100? It makes a difference.
So you can nanocoat coils in the hot caustic method.
Yes. So if you have a possibility to use caustic, I could advise use that if possible. We said at the beginning when are the cases when we use nanocoating by fire. For instance, when you want to do a nanocoating very fast and you have no time for the several weeks required for caustic process. Or another case is when you have no caustic. You have no caustic at all. So then you do nanocoating by fire.
It comes down to your circumstances in which you're in, what you're capable of.
Yeah, it's good to know several ways, several methods, and you may choose in which case which one to use, according to the purpose, according to the urgency, according to the state of affairs or the situation, the conditions in which you are. It's good to have more ways. For instance, how to make a fire. If you know only to light a matchstick or to light a lighter, you can lose your matchstick, you can lose your lighter, and what you do? You starve because you cannot cook a food, or you cannot boil some water to disinfect it if you don't know other methods. So you have to be able, for survival situation, how to make a fire by 2 pieces of wood, by a piece of stone and a piece of steel, and so on. It's good to have a variety of methods. There are other methods of nanocoating too. You can use electric current, and you can use plasma, for instance. So nanocoating by fire is one of the many methods of nanocoating. And it is an easy one, but it needs some practice. It needs to create some skills. And anybody can, if somebody can move his hands and he has eyes that he can see, in that case he can learn how to do it. There is a big silence. Are there more questions?
I think we'll move on. Thanks, Sandor. Thank you very much for all your input there and help.
Thank you for the opportunity. Let's go further.
All right, the final part of today would be making the CH3 GANs. So we'll go through that method. Before, just a quick revision on the definition of GANs. A new state of matter, it's a molecule of a gas which becomes nano of itself and appears as a solid state of matter. So it's a gas to nano of solid, which we call GANs for short. And a plasma or single GANs or single plasma has magnetical and gravitational fields, and your plasma can be made up of millions and millions of fields that come together and spin continuously. So it's your dynamic field interaction, which we explained earlier on. Now, to go on to explaining the CH3, I'm going to review just one or two slides with how we made the CO2. Now, with the CO2, we have our zinc plate and our nano copper plate. And we create an environment between the two plates. And we create that environment which has a magnetic gravitational field strength, which equivalent to carbon, which attracts your carbon from your environment. And so when that carbon comes into contact with the water, it then oxidizes to form the CO2. So essentially we've got the zinc plate and the nano copper, and that creates a certain condition in our box. And we explained last time how because of the atomic mass of the zinc and your nano copper plate being 65 for zinc and 59 for nano copper, and the difference was 6, and that was enough to create a field strength to pull in your carbon, because the carbon has 6 neutrons, protons, and electrons, and we just need 50% of the fields, which is 6 neutrons, to attract the rest. And I remember Sandor went through quite a lot of detail explaining this as well in the previous workshops. So I won't go into too much of that now, but it's just understanding what condition we're creating in our box. So that was our CO2. Now we have to take those same concepts and move into the creation of the CH3 GANs and use the same principles and understanding. So again, just a list of what you'll need. So it's exactly the same as the CO2 box. And now we have our copper plate, but what we need now is a zinc coated plate or galvanized steel plate or chicken wire mesh. Because now what we are doing is we're now introducing a new condition into our box. It's a composite material. So when we have our zinc plated iron or chicken wire, essentially we have zinc coating on the outside of some steel, and in the inside you've got your iron plate. So you're having the composition of two metals, one with your zinc coating on the outside and your iron on the inside. And as before, we now have our nanocopper plate on the one side, and you've got your zinc coated plate or chicken wire mesh on the other side. And the same principles, you just make sure that these plates are hanging and they're not resting onto the bottom of your container. So we've changed that condition in the box now because we've introduced a different plate. So now we've got our nanocopper plate, but now we've essentially got a composite metal in there. So we've got zinc with iron. And as we've explained with the CO2, when we look at the atomic mass of zinc being 65 and your nanocopper plate having 59, that difference created 6, which created that carbon field zone in between the two plates. But now we've also got iron in our box from in the middle of your plate, or even in your chicken wire. And the atomic mass of iron is in 56. So now that comes into play, because when you're having a look at, you've got your 56 and then your nanocopper plate is 59. So the difference of those two is 3. So now we are also creating in that field zone 3 hydrogens. So when you combine them all together, we've got what we're doing with our copper plate and our zinc-coated plate is we're creating our carbon field zone as before, but we're also creating a different field zone in there of 3 hydrogens. And this is just another illustration of essentially what we've got in our box. We've got our copper, we've got our zinc, and we have iron. So we've got a composite. We've changed the conditions in the box. So we've created the carbon. We've got that field zone of 6. We've also created the field zone of 3 hydrogen. So when you add those 3 up, they come to 9. And when we look at our CH3, it is 9. So that is essentially what we are creating in our box is the CH3, because we've created the conditions to attract what we wanted in our box. So by adding in your zinc-coated steel, you've created an entirely different condition in your box, because the whole purpose is to create the attraction field zone for carbon and hydrogen so that you can make your CH3. And CH3 is the essential sugar of life on this planet. It makes up everything that is required for life, forms of sort of building blocks for life. It gives the energy for us as human beings, for your plants, for your insects. Everything that requires energy needs the CH3 and uses CH3. We extract it exactly the same way as the CO2 and the zinc we explained in previous workshops. You can syringe it out and place that GANS that you've collected in a separate container. And of course, one has to also wash this GANS because it will also have salt. So you need to wash this to get rid of and reduce that concentration of salt. And you do that by, the GANS that you've taken out, you've extracted from your box, and you've put that into a separate container. You just add distilled water into that and allow your CH3 to settle down to the bottom. The CH3, because it's lighter, takes a lot longer than the CO2 or your zinc to settle down to the bottom. So you need to give it more time to settle down. And then again, pour all your water off and then just refill with more distilled water. And then you can repeat this 15, 16 times to ensure that the salt is washed out. And Sando explained very nicely the last time the science behind the washing and the dilution of what you're starting with and what you're wanting to end with the salt. And also, with every GANS that we make, we want to collect the amino acids that form on the surface. So after a few weeks, you'll notice a shiny layer or surface on your top of your box on the water. And this is your amino acid. That's the oily amino acid of the CH3. And to collect this, one also takes a plastic spoon and you scoop this off. and place this in a separate jar. And this you don't need to wash. You just store that in contain a label and store when you need. And as this amino acid has a link with the iron, now we have a connection with our blood, because as we know, our blood contains the iron as well. So just to go into a bit more on the concept of the amino acids and what we explained in part 7, is that we have our carbons, oxygens, hydrogen, and nitrogen in a plasmatic form with the addition of salt leads to the creation of the amino acids. So as that is happening in the atmosphere, we explained, this is also happening within your boxes that you are making, whether you're making CO2 or copper or CH3 GANs or zinc GANs, you are also creating the condition for the amino acids to form. And as we've explained as well, the amino acids then in interaction with the copper gives us the muscles for the man. Amino acids with interaction with the iron gives us our blood. And when we look at the plants, those same amino acids with magnesium gives you the sap or the blood of the plants. So the amino acid that forms on our boxes on the water is the connection to the atmosphere of this planet. It gives you your C carbons, oxygens, hydrogens, and nitrogens. And it's in connection with the salt water, and we then have the GANs. So the amino acid we produce in our different boxes will have a connection with our body. So depending on what condition, which GANs we're making, it's going to have certain connections with our body, certain applications. And a lot of this comes down to health applications as to when and where we will use these amino acids. So the different amino acids that we produce in our boxes. So when you're looking at the copper, that will have the connection to our muscle and the physical aspect of our body, which transmits electrical impulses throughout the red tissue. The zinc is connection to our emotion. And then when you're looking at the zinc and the iron, especially with the CH3, you're looking at the emotion being the zinc side, but the iron is the connection with the blood. And as we know, the blood carries the emotion within the body. So by producing the CH3 and having that zinc iron connection there, we know that that has a nice direct connection into the emotion. And CO2 is connection with the amino acid structure of our body. And as before, in anything that we do, whether we're nanocoating or making gases or making plasma devices, it all comes down to our intention when we're making them. It's at how you feel, what your emotions are at the time that you're setting up and making the gases will all have an impact on the outcome that you are wanting, because it's our thoughts and our energies have the maggrav field, and these are transferred directly into the box and gases that we make. So when we are making anything, particularly if we're making something for somebody else, is to have that intention of healing and wanting to help and somebody else, and you're putting those maggrav fields into your gases that you are making. So this is very, very important for you to really almost sit down and think of before you start anything, as to what is your purpose, what is your intention that you're wanting to create with anything that you are dealing with. So any questions on the CH3?
In choosing our galvanized mesh, one of the questions that I have is, do we just assume that it's iron and zinc that's created that galvanized. If you're using a hardware cloth, for instance, you call it that for chicken wire mesh. Are we just assuming then that it's zinc and iron and not something like tin or titanium used to create that coating?
Don't assume, ask the manufacturer. Ask for the technical specifications of the product.
Yeah, what I've done when I've looked for my plates is I've gone into the hardware store, and it will label. You will see the label there whether these plates are being galvanized or zinc coated. So then you know exactly what you are dealing with, and so don't assume, because as you say, you never know what that coating could be. It might look like zinc, but might be something else. So always just check and make sure what you are purchasing.
Jim?
Yes.
Has anybody tried hot dip galvanizing process? Because there's a big difference between electrolytical galvanizing and hot dip galvanizing. I don't know if you know that difference.
There is a difference, but at the end of the day, you are still ending up with a layer of zinc on your iron.
Yes, but what you're interested in is extracting the iron field from inside. Now, in hot dip galvanizing, you got the zinc on the outer surface, and you got a middle surface, which is an amalgam between iron and zinc, that would be an interesting experience. I'll try it out, because you've got an interaction between iron and zinc in that middle surface, which could produce a different effect, to produce some different CH3.
It might or might not. It would be such a tiny bonding between the two there. So I doubt whether it would make a difference, but I'd try it. And as you say, let us know if you see any
And the
difference.
hot dip galvanizing is pretty thick. It's not all that thin.
Not necessarily. Not necessarily. There is a hot dip zinc coating, which has the thickness of 20 micron, and there is another one which has the thickness of 200 micron.
Yes, I know, but I worked for years on hot dip galvanizing, and it's thin when you wipe off the zinc with amianto. What was it? Amianto is this non-flammable product. I forget now what the name is in English, which is bad for breathing, which they used to use.
Fiberglass.
Not the fiberglass.
Asbestos.
Asbestos, that's it. You use asbestos rope or flannel to wipe off the extra zinc off the surface, because not to make it so expensive. But the important thing is the amalgam you have between the zinc and the iron, because the hot dip process takes about 5 minutes, and it has that effect.
Think in terms of fields. So what fields could be there?
Well, that's why I mentioned this, because the fields must be pretty different. You've got the iron field in the center. You've got this amalgam field in between, and then you've got the zinc outside. And what you're interested in is the field effect of the iron, but it could make an effect on a more emotional CH3.
Oh, yes, we usually don't go so much in details. You know, you have an apple tree. It makes many apples. If you taste 2 apples from the same tree, they may taste slightly differently, but they are still apples.
Yeah,
of course, there may be differences because one was from the north, the other from the south, other from east, other from west, from the branches of the same tree. So there will be no 2 apples which will be exactly the same. So same with all kind of these coatings, you will not find two pieces which are exactly the same, but as the apples from the same tree are still apples, and even from different trees, even though there is a little difference, so it happens with the galvanized zinc-coated iron as well.
Yeah, but
I would have more concern about the carbon content of that iron. I would have much more concern about that, because you may have such hardware parts which are galvanized steel and which have a higher carbon content, and you may have a soft wire, for instance, which has a less carbon content. So that would make a more difference.
Yeah, you're right there. Now, in an apple tree, as you say, you've also got apple trees which have been injertados, where you put some other plant and gives it another property, and part of the plant will give you one type of apple and part of the plant will give you another type of apple.
Can we just stick back to the topic? Are there any other questions, please?
Yes. How about a galvanized bucket, cutting a plate out of a galvanized bucket, or galvanized pipe, like galvanized duct pipe or flue pipe that's galvanized, and cutting a plate out of that and using that rather than.
Of course, you can ruin a brand new good bucket, or you can just buy some cheap zinc-coated soft iron wire. You take a bunch of them and you have the same result, but with less costs. So you can use whatever zinc-coated iron you want. I wouldn't ruin an entire bucket for that.
No, I'm just looking at the options there, that's all. So when you're using the mesh, you don't use one layer, you maybe fold it over into 3 layers.
Look, sometimes, not sometimes, very often, let me share my screen or a small drawing, you just find such a bunch of wire, such a thin wire, which is galvanized wire, which is used in many places in industry and in agriculture just for tying together. For instance, when they work with those, oh, sorry for this color, when they tie together those metal bars, which they want to make concrete, they use such kind of galvanized wire in order to make the bondings, and it's very cheap. You can get a spool of a ½ kilogram, for instance, for $2. It's not expensive, and from there you can just take a bunch of these wires, and you have enough surface to put it in your vessel with salt water, and to put here nearby a bunch of copper wires which you nano-coated. So you have already made your CH3 kit. And it's much cheaper than to use a bucket. If you have nothing left, so you are in the middle of apocalypse area, like in the Mad Max movies, and you find a galvanized bucket, you know it's a treasure because you can make a CH3 gas out of it. But otherwise, why to ruin it?
Well, that's maybe good, but you know, and a lot of people in construction or things you do around the house, and you have a piece of pipe, like duct pipe or flue pipe or vent pipe that's galvanized. I just happen to have a lot of scrap around. I know other people do too. It'd be very easy to cut a plate out.
Yeah, when you cut it, don't forget it. When you cut it, you will have an open edge which is not galvanized, and that changes the game. So you have a bigger surface of iron, pure iron, exposed to salt water. So probably into your CH3 gas, you will get a mixture of many iron oxides and also some hemoglobin at one stage of production. And if all the surface is coated, you will get a more pure CH3. As per my opinion.
Okay, that's an opinion. Okay. Well,
Otherwise, you can find such a small hardware bits, pieces, which are used to mount on doors, on locks, and so on, or hinges, or whatever, which are galvanized. You can hang them on a wire into a vessel with salt water. You pair it with a bit of nano-coated copper wire or a copper plate, which is nano-coated, and you can produce your CH3 GaNs. But preferably soft wire is better because it's less carbon into the iron which is inside. When you have a piece of hardware, it's usually made of a steel with a specific tensile strength, and it has obviously more carbon.
I find, according to this question we got in the chat here, we get CH3 when there is no more free oxygen in the water. We've still first got to consume all the oxygen, the free oxygen, which the fish need in the water. And then we get the CH3 when we have no more oxygen. So the best thing is to use the most stagnant water, which has no oxygen in it. Is this true?
When you set up your CH3 kit, you will observe in the first hour it will produce white GaNs. That will be a mixture of CO2 GaNs and zinc oxide GaNs. So the oxygen will go there. And after a couple of days or sometimes weeks, it depends on your conditions, it will appear that orange color GaNs. So the process has some cycle. So there are different processes at the beginning, then other things happen later.
Well, that all depends on the quantity of oxygen you got to dilute it in the water then. That's what I'm saying.
Yes, of course. So you don't use oxygenated water, just the plain water. Every water contains some dissolved gases, some nitrogen, some carbon dioxide, some oxygen. And when sorry, when you start making your GaNs, first time you will get the GaNs of oxides, like a carbon dioxide and zinc oxide. So part of the free oxygen of the water will go into that CO2 GaNs and zinc oxide GaNs, which will be a deposit of white color. You can keep removing that and then wait when it will be produced that orange color CH3 GaNs. And why you remove the first white GaNs? Because if you leave it there, your kit will start picking nitrogen from air, and it will produce a lot of amino acids on the top, which is not desirable at that stage. Just do it and just follow day by day how it evolves, and you will learn a lot just by observing it.
Are you saying to draw off the initial white?
Yes, of course.
How do you do that?
Do you have a 50 milliliters or 100 milliliter large syringe?
Okay, so you just pull it off of the syringe, say for the first 24 hours.
Not 24 hours, until it produces something white. When it starts producing something orange, that's a different thing. That's the CH3 GaNs.
There's a good example from Diane in the chat. She says, I used galvanized nails to make CH3 GaNs. The first 2 batches came out white. The third batch, made from the same materials, was a charm and came out the CH3 GaNs color.
Yes, this is normal.
That's a good example, I guess.
So are you, in this, do you recommend using a LED light?
You can use or you cannot use. It depends of what you follow to obtain. By an LED light, which you put in series with the 2 plates, you are reducing the currents. The production will be a little slightly slower, but it will be a different quality.
Normally use the LED only on the CO2 kit.
Oh, I'm using also on the copper oxide kit. Ask Armen Guloyan, he also uses it.
So in the CO2, we get a significant difference in the GANs when you use or don't use a LED light. And you're saying that it's not significantly different in making CH3.
It makes a significant difference because if you don't limit the currents, you will get a lot of zinc going off your zinc coated or zinc galvanized iron. The zinc will last longer if you limit the current. You need the fields to work by the power of the fields and not by the power of the electric currents. If you want something produced by the power of electric currents, then go to a shop where they're doing galvanization and you will get a lot of galvanic mud or sludge, which is a different thing.
So just to clarify, I'm sorry, it's a little hard. You're saying we're likely to get a better CH3 by not using an LED light.
I'm using an LED light even there. You can choose to use or not to use. You will have a different current and you have a different condition. You can do in both ways and compare the results.
Okay. Thank you.
Which is the method that's recommended in the new workshops for the Kesh Foundation workshop teachers, I wonder? There must be one way or another with that one.
So people shall come to an agreement about. So no method. So I just share this to show you the color of the CHP GANs made with diode in series.
Nice.
So this is after I picked up from the bottom of the plastic with a syringe. You see its aspect, its color. It's not a muddy brownish color, it's real orange color.
And then do you have a picture of the CH3 without a diode?
No. I was looking for it, I didn't got it. I have here such external hard drives, but I didn't connect them because I'm traveling.
Yeah, I understand. It's no problem. There was a question. Can you clarify the difference between caustic and fire burning method? Is it in relation to, is one better than the other for GANS purposes?
Preferably use nanocoating by caustic, preferably. But you see, in some places you have no other choice than to use the fire.
Okay, there was another question in Facebook. So the zinc coated plate has the fields of 59 down to 56. When we mix fine iron and fine zinc powder, do we have the same?
Fine zinc powder?
Yeah, I'm not sure what they were asking, if you could.
Where from that idea? Because we didn't talk about that.
It doesn't make sense to me.
So how about it we add some salt and pepper? So we can mix up so many questions, but what's the reason for asking that?
Not sure.
Maybe they're thinking that that it would be the same combination, but it's different because of that 5%, especially, right? The difference between the nano-coated and the element. And if they were just making powders, that would be of the element, not of the...
No, 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 no. So please understand. So now you have a piece of iron here. And you have on the other side a piece of nano-coated copper. It has a coating outside, and this coating does all the magic, yes? And these are connected together. Now, if this would be a bare copper, if this would be a bare iron only, in that case, the iron 56 will be still attracted by the fields of 59 of the nano-copper, because they are very near one to the other. It's a small difference only. And iron would start to go into the solution, would get combined with the oxygen from the water, and would make a lot of nice iron oxide, which is commonly known as rust. Is it so? But in our case, we have a packing, a shirt of zinc, and this makes a difference. So all the iron is packed into zinc. So the iron is not in contact with the water. You just have the fields of iron and the fields of the zinc interacting with the fields of the copper. It's quite different if you put pieces of zinc. If you put in a vessel just a piece of zinc and a piece of iron and a piece of nano-coated copper, and you connect these together. So in that case, you will get a mixture of gases, and you will get also hemoglobin, because finally you will get here some amino acids, and that in contact with the iron will produce the hemoglobin. When you make the CH3 gas, it's good to have a shirt of zinc over the iron. You don't want the iron to dissolve into the salt water. You see why people are galvanizing pieces of iron to resist to the water. Pieces of iron which are exposed to rain, or they have to be in the water, usually they are galvanized. They are covered with a layer of zinc. Also the inner layer of your boilers, which are made of iron, they have an inner layer either of zinc or magnesium or whatever, to avoid the corrosion, the slow dilution, discomposition of the iron into the water. So if you think about mixing powders of iron, powders of zinc, which otherwise are quite difficult to obtain, you will not get anything like that. But thank you very much for the question, because we could clarify about this. It's important to have this shirt of zinc around the iron, and to have no iron exposed directly to the water. Otherwise you get rust, and you don't need rust. You need here CH3. How much iron you see in CH3? It's carbon and hydrogen, iron none. If you have the iron opened without to be covered by zinc, probably you will have a lot of iron oxide too, and it will be a different kind of mixture. Are you satisfied by the answer?
So,
but when you cut the plate, the galvanized plate, you always expose some iron.
Yes, that's why I prefer to use a galvanized wire and not a plate.
Okay.
That's why I prefer to use a galvanized wire, which I can bend it in such way that the cut ends to be outside of the water, not inside. Or a galvanized piece of hardware, which is one piece of steel which is galvanized, and it's galvanized everywhere, and just I hang it on a copper wire and it's fine.
But you're still cutting the galvanized mesh.
No, yes, and you can bend it to have the cut parts outside. There are many ways how to bend it.
Very good information. Also, probably with your wire, you call it the tie wire, you have a soft iron. With sheet or plate or even nails, you're likely to have a higher carbon content because you don't want it to bend. So a nail will have higher carbon content to make it stronger.
Yes, and in the same time, when you have a nail, you have to know that the nail is usually an alloy of iron which is rich in phosphorus. So that also changes the condition.
So at any time, if the zinc coating comes off, is gone,
yes,
eaten away or used up, you have to replace your specimen that you're using.
Yes. So best thing is, by my humble opinion, is to get such a galvanized tie wire, which is used for tying together. And the thinnest is the better.
Beautiful, thank you. That really helps cut down the amount of experimentation that we're doing, and which I still agree with very much, but you're sharing your experience is a great help. Thank you.
You're welcome. Just let me open a picture of the tie wire and to share it you to make sure for all speakers of English and not in English and other languages. One picture tells 100 words. And let me find that right picture, which I just saved it on my desktop. It's on the yes. And here is the sharing button. So here is one option of tie wire. Here's another one. This is a thicker one. The thinner is better. It's cheap, soft, it's easy to work with it.
Okay, I had a question on YouTube from Renee. Can you tell me something about reproducing the GANs? Every time I try, the result is much different. So if something is not replicatable, is it not good at all?
So it's a good idea when you do such an experiment to get a small school copybook, a pen, and write down the conditions you used for your first experiment, how you did the nanocoating, how you have chosen the materials, what was the time of the day, was it morning, was it night, was it evening, or middle of the day, was it, how much was the temperature, was it 20 centigrades or 30 centigrades? And in that case, you have a chance to easier replicate the same conditions. How much salt you put, what kind of water was it? Two eggs are not the same. Always there is a small difference in between. So also when you make GANs, there is a tiny difference, but you have to be able to replicate. If you made the CHT GANs, to be again CHT GANs, if you work clean in a tidy way. So without extra information, I cannot say more. If the person who asked could give more information about what was the difference. So once he made something and it was a purple color, next time he made something and it was an orange color, or it was a turquoise color. In that case, I understand what's the difference. But that he could not replicate, I don't understand what he couldn't replicate. So what was the difference? What was the difference in setup? What was the difference in the results? So if you could ask more in details, we could give a more detailed answer.
I have a question about surface area. So do you want a similar surface area of nano-coated copper and your zinc-coated iron?
Not necessarily. Of course, if you have a huge surface area of nano-coated copper and you have a tiny surface of your zinc-coated iron, you will not utilize the whole surface of your iron. So it's good to be in a good ratio, one to the other, but it doesn't have to match exactly by square millimeter. By the way, there are several ideas, such a hints. So you can use, for instance, you have a bottom of a plastic bottle cut off, or you have a small plastic bucket, or you have a small plastic box like used for food, of course cleaned, and you can put inside a different shape of metals. So you can use, for instance, a stripe cut from a plate, from a zinc plate, for instance, or such a piece of copper. Or you can use such a bunch of copper wires which are nano-coated, and they are just put together. You can put the bunch of wires open, and you see the fields will be different. So here they are tied together. So these are in the box, and you have different spread of the fields if you spread these wires. Again, you have a much different result if when you put your nano-coated copper wires inside, you bend the ends towards up. You give a different direction to the fields. And here you put your other wires or plate or whatever. The way how you bend its end, it makes a difference. You can make a difference by, for instance, putting in a round shape a piece of, let's say in our case, in case of CH3, like a galvanized plate, for instance, and put in the middle such a copper spiral made of a bunch of wires, or the multifilar wires. So if you put this around, in that case, you see the fields are going in all directions, and you have a more active surface. There are so many versions what you can do. Just remember, try in this way, try in that way, and observe the difference. Always note down what you did and observe the difference. Just by doing this little bend here, just bending the ends, you get a different result. You get different result when the wires, such a bunch of wires from a multifilar cable are just straight, or when you spread them. It makes a huge difference. You see how the grants will be formed in this case or in the other case. You don't have to work now with many liters of salt water and big containers. Work with tiny, small containers of the size of a cup, and several of them, and see what's the difference if you change something, the shape of the metal you use, its positioning, what is in its neighboring, and so on.
Thank you. There were a few questions in the Q&A section. Yeah, and I did answer them, but they probably should be covered just so that everybody else knows about them.
Yeah, one of the questions is not a question, it's an answer to Mr. Flint from Mr. Teomanta. I know, Flint, just ask for other people who might have this problem. Okay, so this was answered.
They're under the answered section there.
Okay, Klaus-Peter Pavelka, the atomic weight from copper, sorry, not from, but of copper, is 63.546, like PSE. How do you know that the atomic weight from nano-coating copper is 59? So now let's clarify the atomic weight of copper. It's not 63.546. What you see in that table of elements, in the periodic table of elements, it's a mathematical average. Because when you have copper, usually you don't have a pure copper of isotope 65 or isotope 63, but you get a mixture of both. you get a certain percentage, let's say 29% of one kind of copper, 71% of the other kind of copper, which are mixed together. And always we work with average numbers. Now, in case if you make a nano surface, you create nano layers from a material, you have to understand nanostate as a different state of matter, different from the solid state. It's a different bonding of the atoms. And if you understand how the protons and neutrons will behave in a plasmatic state, you will understand that little weight reduction from average 63.5 or 64, let's round it, down to something between 58 and 60 or 61. We say 59, but it can be 58, it can be 60, it can be 59. It's just an average. What is easy to understand, what is easy to remember is that when you go from the metal state, from the solid metal state, you go to the nano state, the matter gets more spacing in between, gets more loose, and that will produce a reduction of not the atomic weight, but a reduction of the strength of the fields. So we use, yes?
May I ask a question, please? Thank you for
yes, Caroline?
Thank you for your broad knowledge explanation. I'm learning too, but something raised the question with the question from Paul. Have you gone back to the teachings of Mr. Kesh and have you corrected the table? Because he says that the existing table is not correct.
The periodic table of elements.
Yeah. Have you brought this into our teachings?
Not
because
yet.
people,
there are so many ways. Yeah.
People are still working with the old table, which is not correct. So if somebody could do some research in the teachings of Mr. Kesh and bring the correct table forward, then people will be less confused.
Yes, and in the private teachings, Mario Train has covered that in about 4 or 5 sessions on the new periodic table that's spiral.
Yes, but he does it just in the opposite way. From the light is in the center and the heavy is on the extremities.
No. He said
hydrogen's on the outside.
Already. Okay.
It spirals in. So, but that's all in the private teachings, which is about a good 20 hours of teaching there.
Yeah, we have to work out, according to Caroline's suggestion, we have to work out an easier graphical representation, and not just to represent the isotopes, but also the isobars.
Maybe it will be okay to ask this and bring this forward to Mr. Kesh for next Thursday to bring the light onto the periodic table, which is correct. And then he can expand to everything, and people keep your pen and paper ready. Because for Mr. Kesh, it's easier to go back to it than us searching through all the teachings to find it.
Yes. So now for
and the periodic table should then be distributed to all the knowledge seekers and should be appearing on our website.
The right one would be something made in 3D, not even in a sheet of paper.
It's a good suggestion to bring it into the managed meeting. Yes, Rick?
So what makes it more interesting that we have not just isotopes, isotope meaning those elements which stays on the same topos, on the same position into the periodic table of elements because of the same number of protons. But we have also isobars which have the same weight, which can be, for instance, copper 65 and zinc 65. Or potassium 40 and calcium 40. They have different number of protons, but they have total number of protons and neutrons together. So total weight is very similar. And from plasmatic viewpoint, that's also very important for our studies. And to Klaus Pavelka, I would suggest to find those teachings where there is explanation about the difference between gravity and between inertial mass, and how this is done by the interaction of fields. So then we will understand why, not the atomic weight, we are not working with atomic weight, why the field strength of a nanostate is different than the field strength of the same element in a solid state. And yes, we will work on better periodic table of elements, which would be very useful tool for knowledge seekers to work with plasma fields and to understand the strengths, the plasmatic strengths of different elements.
I have a question about the salt.
Mr. Nicholas, you have so many questions today.
Well, these are practical questions. So if is there a difference between choosing the salt, especially for health uses or agricultural uses, to make your salt water from a mineral salt, sea salt, or to really know your salt?
Okay, let me say you something about a mountain salt or a mine salt and a sea salt. So actually the term of sea salt or mine salt or a rock salt doesn't tell you the chemical composition, because a product can be marketed as a sea salt, which product is pure sodium chloride, or can be another salt which has very less or none of sodium chloride and just have the rest of elements like a potassium chloride, potassium bromide, magnesium chloride, magnesium sulfate, and other salts. So the name itself, which shows this source, whether it's from the sea or whether it is from a mine, that doesn't tell you about its chemical composition. To know the chemical composition, you have to ask for manufacturer's data sheet or a certificate of analysis or what he guarantees that it contains. In many countries now, there are no more strict regulation about what can be sold as food. And you find a large variety of salts sold for food purpose, which contain so many kinds of minerals and elements and additives that you just wonder which is really salt and which is only 50% salt and 50% something else, including quartz, sand, and other things which don't dissolve. So really you have to look for the reliable manufacturer's declaration about what his product contains. By the way, regarding the origin of the salts, you have to know that all the mine salt, so that rock salt, it was once a sea salt. So how the salt deposits formed? There were oceans and seas on that place. Later mountains have been created and the water evaporated and the salt deposited in layers, which is now under earth. Now the important thing is how it is refined, because if you just get a raw mixed all-in-one sea salt, in that case you have really everything of all the elements of the earth, of the planet. And that's not the best way how to control your result, because it can be at random. If you want to target a specific result, you may want to work, for instance, only with magnesium chloride or only with sodium chloride or only with potassium chloride. It depends on the purpose of what kind of gas you want to produce. You see, for instance, Dead Sea salt. I go in a shop near my house and there are packs of Dead Sea salt. Both are written Dead Sea salt, and one pack is for food. It's 99.95% sodium chloride. from the Dead Sea. In the other bag, it's also Dead Sea salt, but it's not for food, because it would poison you if you would put that in your food. But that's for a spa, for a bath. You put it in water in your bath tube, and you wash your feet in it, or you immerse your body, and it makes good to your skin, but never drink or eat that. And both are named the same. It's a Dead Sea salt. Just it have different purposes and different composition. You have to look to the composition, not just to the marketing text. Also, the salt mines, they have a salt which is mostly good for food, and there is such a cover salt which is mostly, let's say, potassium chloride, or mixture with any other elements, or with earth or whatever. Ask for the chemical composition of the salt and verify your supplier whether it is reliable. Can you trust his words or not? For instance, now not about salt, but about fish. You see, since Fukushima, now in many countries, producers of fish products have to label the product about the origin of the fish. And they say it's fish from Pacific Ocean, or fish from the Atlantic Ocean, or fish from Baltic Sea, or whatever. So you know what risks you have if you buy fish which is from near Fukushima or from the other ocean, from the Atlantic. And I found a producer who was selling its product in one of the supermarkets. He was selling carp, which is a sweetwater fish. And on the label, it wrote that the origin of the carp is the Atlantic Ocean, which is impossible. So if he could put such a big lie on that label, in that case, I cannot trust anything else which is written on the label regarding the other chemicals and additives which they use. So you understand, you have to evaluate how you can trust the information according to its source, because just because something is printed, it shouldn't. It doesn't must to be something true. Sometimes misinformation is also printed. So check your supplier. Check the quality from your supply.
Yeah, the more pure salt, the better.
Yeah.
What do you mean pure salt? Pure salt meaning sodium chloride?
It depends on what you target, what you want to obtain, for what purpose. If you don't know to put your conditions, you don't need to worry about that.
I understand what you're saying there. I was just wondering what the term pure salt means.
So according to a standard, it can be, let's say, 95% purity. According to another standard, it can be 99.99% purity. Find out which is acceptable for yourself.
And others means it's salt, but there's other minerals in it too, you know. Very small amounts of trace minerals like cobalt and other kind of stuff. And just remember, whatever you put in the GANS kit, you're going to be making a GANS of.
All right, we'll have time for one more question.
There were a few questions, or a couple that were pretty basic that I answered in the Q&A, okay, just to make sure people know about them. Do you take the amino acids off the top before or after you've rinsed the GANS? And generally, yes, before.
So it's easier to take the amino acids first, and then to make your GANS from the bottom. Isn't it so?
Yep. And then how to actually connect the plates. What is the best way to connect the nano copper to the zinc coated metal? In whether to use an LED and which way the LED faces with a long pole, short pole on LED.
So it depends again. So I explained in details some lectures ago. about how a diode behaves if it's polarized directly or if it is reverse polarized. How it behaves, it is directly polarized and with a bias voltage below the opening voltage. So if you are below the opening voltage of a diode, it doesn't matter much more, too much whether you polarize it directly or opposite, it still behaves like a resistor of very high value. If you reach the opening voltage, in that case, the game changes. When you have a different current which goes through, which depends on the specifications of the diode. So below the opening voltage of the diode, so be it positive or negative, does not matter, you will have some nanoamperes or microamperes which go through. If you have opened an LED, so you reach the voltage which opens it, so you see a light on an LED, in that case you may have a current of, let's say, 5 milliamps, 10 milliamps, 30, 50, depends on the power of the LED. Usually something between 10 and 30 milliamperes. So understand what you want to obtain and understand what each component does. And in that case, you have a tool set which you can combine according to your own wisdom and inventivity. We don't want to give out recipe now. Cut a piece of 3 by 5 centimeters of butter. We try to give basic principles which people can understand it flexibly, and you understand it and use it flexibly. Like if you have a Lego game, do you need a pattern what to build from the Lego game? No. If you want that, buy a puzzle, but that will not make your child to be more intelligent. It will make just more obedient to put together the parts which are designed by somebody else. But if you buy a bucket full of Lego elements, the child will use its inventivity to make all kinds of new forms which nobody made it before. So here also, it's better to give to the people the ways, the tools of the logic, the tools of the thinking, the tools of the technology, and let you use that flexibly according to your design. Don't just copy, innovate. Don't just copy how long to be a wire and at what distance, how many milliliters to be from the other, how many milligrams of salt you put in what temperature water. If you just follow such a strict recipes, it doesn't mean you will have success. You have to understand it, how it works. You can get a recipe from a cookbook, for instance, to make a cake. It says take 3 eggs, 200 grams of butter, 1/2 cup of milk, 1 cup of water, add a 1/2 kilogram of flour, mix them together. And you will find out that if you have no knowledge about how to cook a cake, you never be able to make a tasty cake from that. First of all, the eggs. It never writes into the recipe, into the cookbook, that you have to break the eggs and to take out the inside. If you just put the eggs with shells, what will be the result? So don't ask for recipes, please. Ask for why and how.
Okay, thank you.
You're welcome.
Yeah. And one last question was from James. In the presentation was given today in regards to producing CH3, the initial white material, is it high in nitrogen and aminos, and would that material be useful in the garden?
Please ask specialists for gardening. I have no garden at this moment.
Well, that initial material is basically CO2, isn't it?
By the way, Jim is here.
Yes.
So he can give you answer.
Just to ask that question again, Flint.
Okay, he says, in your presentation in Plasma Science today, in regards to producing CH3, the initial white material is high in nitrogen and aminos. Would this GANS material be useful in the garden?
I think you misunderstood. That initial material is zinc and CO2,
And the amino acid that you're forming on top will contain nitrogen because it will have carbon, nitrogen, oxygen, and hydrogen. So it's the amino acid which would have the nitrogen component, not the GANs at the bottom. Does that make sense? Hello?
I was seeing if you reply there, but it does to me, but it was written in the chat there.
Yeah.
Yes, it does make sense.
All right. So that's it for today. Once again, thank you very much, Sandor. A lot of useful information and a lot of good questions, which helps to bring out the knowledge as well. So thank you for all those for the good questions. And thanks, Flint and Rick, once again. Thank you very much.
Thank you for the opportunity. Thank you for the good questions.
And you're welcome, Jim, and thanks for the great series here. A lot of people are suggesting that it's very useful for them.
Okay. So that's it for today. We'll be continuing on, obviously, next Monday with part 10.
May I ask you something?
Yes, Caroline.
When do these classes usually finish?
For these teachings here, we usually, well, the target time is usually about an hour and a half.
Oh.
For everything. And so, but obviously we do go longer because there's always been a lot of questions.
So usually you go only for 1.5 hours.
But lately, the last
few, I think most of them are more like 2 or 2.5.
Yeah, there's most of them always end up being around 2.5.
We've achieved an hour and a half, I think.
Do you want to have an insight in the soul to close the teaching?
That would be fantastic.
We don't mind.
Yeah, this week was on the plasma science, nanocoding, and GANs, and next week is going to be on health and soul and nature. And every other week it changes.
Because I heard, yes. I can't remember if it was Jim or Sander, about the intent before you start. As I hear through the series of questions which are coming, which are beautiful, and thanks God we have good teams which can follow up. But I wanted to give you a gift, which I gave to my boy this morning. He was struggling with certain things, and as children are so young, they look at things totally different. So I give him a few days, or maybe by tonight he might be giving me a fantastic answer back, I hope. It all depends if he remembers how to work with it. But as we're driving to the school, he said to me, you know, Mama, when I'm driving with Papa, I have totally different conversations than when I'm driving with you to the school. I said, yes. He says, with Papa, it's always maths and science. And he looked at me. I said, and with me, he says, you can talk about everything. I said, no. I said, Papa is focused to guide you in what you need to know, because it opens so many doors for you in your school projects, and he wants to make sure you understand. I said, now, I asked him a question. I said, does the yesterday exist for you? And he was quiet. I said, does tomorrow exist for you? He says, no. So I said, yesterday and tomorrow do not exist. He says, yes. I said, then what does exist? And he had to think. About today, he says. I said, no, no, no. I said, now exists. You are in the now. I said, and with what you have gathered from Papa and from me and from listening to the teachings and all our discussions or talks, sharing knowledge, I said, if you're in the now, I said, your body is composed with trillions and billions. I said, I don't think there is even a number to be placed on of atoms. He says, yes. I said, but you know that these are all energy. He says, yes. I said, now, if your body is the vehicle of your soul, which is the complete source of energy, I said, if you request and you create, let's say you want to achieve something, I said, your body is talking, but to your soul. I said, if you learn the communication level from your body, your physicality, which is a composition of so many trillions and millions of tiny little energy sources, I said, you're still walking composed, aren't you? You're one body. I said, you're not in little parts everywhere. He says, no. I said, so if you're in the now, that means through your emotion and your thinking, you create now, not yesterday and not tomorrow. I said, so if you want something to be created for you, then you have to work on it now, not wait till tomorrow, and definitely not in the past and yesterday. He says, yes. I said, so if you have found, and if you find a secret to communicate through your physicality, to talk to your soul, for it to create the opportunity in your physicality, I said, then you can create anything, do you? He says, yes. I said, why don't you start working with it? I said, whatever thoughts go through your head, be careful what you think. I said, what emotions are going through your body, that you can feel them. I said, take good care of them. I said, because that is what you're creating for it to appear wherever you want. I said, that's the secret what Mr. Kesh has been, or your Papa has been teaching. Before you start, be aware how you are, what you are, and you're in the now. So you're creating now, not tomorrow, not yesterday. So at any given moment, you can recreate even if you made a mistake. You can reset anything by recreating and start a new creation today in the now. So if you're going to start creating ganses and nanomaterials and nanolayers, and even your life and the position where you are a creator in the now. And it changes instantly, because Rubin fell yesterday rolling off the hill in the snow, and he rolled against a pole. And he says, Mama, my back is hurting. I didn't see it. It was so tiny, he says, but I still hurt myself. I said, now it's the same that exists for your body in your physicality. I said, go and talk to your soul and tell her or ask him, either way you want, say, pain doesn't exist. I said, it will disappear because it can remove it. I said, when you keep on re-emphasizing that you're in pain, then the pain will be present because you are keep on creating or repeating, I have pain. So when you create and you go to your soul and say, pain doesn't exist for me, I said, it should disappear, wouldn't it? He says, yes. And I let him wonder and dwell on it. And it takes me half an hour to get him to school. Before he got out of the car, he says, Mama, you know something? My pain is gone. I said, you see, it works. You are a creator, so you can create anything you want. He said, bye, Mama, with a smile on his face. So you knowledge seekers, you got the secret of the universe. You create now, instant, and you can adjust your creation if you're not happy with it. But make sure what you create is beautiful. Thank you.
Lovely. Thank you.
Thank you so much, Caroline.
You're welcome. As Rick said last time, be careful with what you wish.
It just might come true.
It comes true for sure. Don't worry. Because I emphasize on it because Mr. Kesh, after last Thursday teaching, he said if people could only understand what has been opened up and they found a path to work with it, they will change this planet in no time. So you're in the now, you're connected, and you're the creator. But you got to visualize what you want, exactly how you want it. And I went on this one because Rubin has a problem teacher. And as I was explaining, I said, now you imagine before you walk into the school that she is a happy teacher. She has a beautiful smile on her face, but she hasn't, he said straight away. I said, I know, but if you emphasize it, she will stay this way. I said, but you can change her. I said, but you have to visualize it in your head that you know her face, you can change her. I said, try, we'll see today. And that's the beauty of what you can create. I'm going to leave you because otherwise you're going to go over your 3 hours.
Thank you again, Caroline. Okay, thank you everyone for joining us today, and we'll be seeing you next time. Don't forget, the next public meeting here is going to be tomorrow afternoon, 4 p.m. Central European Time for the 18th One Nation, One Planet, One Race for World Peace meeting. Have a wonderful rest of your afternoon, day, morning, or evening, and we'll be seeing you soon. This has been the Kesh Foundation Spaceship Institute Public Teaching in English for Monday, November 20th, 2017, with Jim and Lisa McDonald and also Shander Kakashi. We'll go out with some music here and see y'all soon. Bye for now.